In this question, we'll be exploring tools like ls that you probably are very familiar with, exa, which is a little newer, and tree, which I absolutely love. And before we get into the meat of the question, I want to run a scenario by you. This may sound a little familiar, but just use your imagination. Say, I have a friend who did a little bit of programming at his previous job, and he just started a new job, new hire, and he has to completely switch up his workflow. His old workflow liked using his Windows laptop. He programmed in VS Code, something, a lot of point and click, very comfortable, easy to navigate. And then at his new job, he was given a Linux machine, right? Less desktop, more typing, more command line, and Vim. Absolutely no pointing and clicking, right? So this is very new, very strange. But instead of feeling defeated by the challenge and just catching up, right, just getting to the bare minimum, he wanted to advance. He wanted to see what else is out there besides some of the old tools that his new job wants him to use. He wants to use that new shiny things. So he started exploring modern tooling, right, modern command line tools, that is. And one of the very neat things about exploring modern tooling is that we get to understand how the uses for these old tools have evolved into a modern time, right? What do we do now with these programs that we didn't used to do or didn't even need to think about? So what are some of the convenience and features that a lot of modern toolings have? It really highlights how developers and the developer workflow has changed from the pre-2000s even to the post-2000s. So before I give any more background, let's get started. ls. What is the point of ls, right? Is it to do something in the terminal when you're bored, when you're not sure of what to do next, or when you want to feel productive? I don't know a single soul who can resist opening up a terminal and not just typing ls, just to see. I see my home directory every day, but still every day that I open up a terminal, I type ls. I just want to see what's there. I don't know. It feels good. But what does ls really do, right? It's not just some productive countermeasure. ls allows us to examine the contents of a directory. And now what's all this hubbub about it being replaced, right? ls was probably one of the oldest tools that we're going to talk about today. Does it need to be replaced? What's so cool about the modern stuff? Well, I'll let you decide that, because I do know one thing about modern tooling is that this is kind of a picky conversation, right? People are on one side or the other, and I hope to give you the knowledge to make the decision for yourself, or even introduce some new tools that you just haven't heard of, just so you know what all is out there. So what are the modern alternatives to ls? We have things like tree. We have things like exa as well. And the thing about tree, what sets it apart from ls even, or exa, and is that it allows us to examine the structure of a directory, right? Not just the contents. So I have an example with tree here. An example is just the name of our parent directory. And when I run this, we see that we get this very nice output. Look at this. I can see everything that's in this directory. It is very nicely color-coded. I can see the entire structure of it, which is fantastic, right? If you're given a zip file, you unzip it, and then you just want to see what's in it, bam, tree is your go-to command. The fact that it's recursive by default allows you to see everything that's in it very easily. And you can achieve kind of the same thing here with ls, but we need to set the recursive flag option, right? And so now when we run ls recursively on this directory, wow, we see there's a lot of text here. It is very hard to make heads or tails of this. I would really have to spend some time picking this apart and exploring through it just to see what's here. This honestly is the reason why a lot of computers have a windowing system. If I wanted to see everything that was in this directory, I honestly think it would be much easier to point and click and navigate on my own than to try and parse the contents of what just came out of this recursive call to ls. And that is what tree allows us to do, except it saves us, right, from having to open up a graphical user interface, and we can do it right here in the terminal. But, ls also has color to it, right? I don't want to discount that. So to see a colorized output, we just set the color flag to auto, and we can see we get a little color here. Does it help with the readability in this recursive call? A little bit, yeah, but it's not really changing my life like the output of tree did. And in fact, this color option on ls is so common, I'm willing to place money on the fact that every single developer has an alias like this in their bash aliases or their zshrc, whatever shell you're using. I almost guarantee you have some type of alias for ls, and that way, whenever you call it from your command line, you get the nice colorized output. But what if we just want to see the directory structure, right? I don't care about all the files. What if you have a bajillion files and I really just don't want to see all of them? I'm just curious about what does the structure look like? And here from our tree command, we can see every single directory. We don't care about the files, but I can see that, oh yeah, there's one folder that's just really unnecessarily long and nested. And we have a couple others here. And actually looking at the highest level folders, analyses, pre-processed, raw, reports, scripts, this seems like a data science project to me. And so these are the types of observations you can get by using these types of tools, right, that really allow you to explore the file system tree. ls, you can't really recursively call ls to look at all the directories. You can do a little bit of workarounds with pattern or with glob matching and shell expansion, but it doesn't quite get you to the same place that tree does. Another very neat thing that we can do with tree, and this took a little bit of inspiration, my guess would be from find. We can limit the depth that tree will search and return for us. So in this example here, we ran tree and we said, only give me back up to 2 levels of nested folders back to me. I don't care about anything deeper than that. So shaved off that really unnecessarily long nested folder, and we can see just everything that's 2 layers deep. ls doesn't really have this option, right? We can do a little bit of workaround, like I said earlier, with some pattern matching, but again, we get that output that's just really hard to make heads or tails of. One other thing that I wanted to show off with tree is its ability to not list some hidden files. So when we get specific files here, we can add this -a flag to include hidden files in the output. It's very similar to ls. And here you can see I've just decided to limit to just 1 level of depth. And so it just lists everything in our immediate directory. This is definitely doable with ls, right? Just looking at the first level. So we don't gain too much from tree here. But what we can gain from tree, which is intensely powerful in my opinion, is the ability to perform true pattern matching on files, right? This is not a shell expansion. This is tree actively going through and searching for any file that has the pattern .csv, that ends in .csv as a pattern. And what we can see here is, wow, there's a lot of CSV files in here. So this is a data project folder. So we do expect to see some of these outputs. But you probably noticed a ton of empty directories in there. What if I don't want to look at all of the directories that don't have a .csv in them? Well, this is where things like the prune flag come in very handy. We can trim away all of those directories that don't match our pattern, and we can just examine and explore the directories that we do care about, the ones that we're looking for. And so this tree program is very useful in that sense that I can really just get in and explore, just feel around what the contents of my directories are. You can even perform inverse matching. So if I don't want to see any of the CSVs or any of the Microsoft Word documents, I can use the -i flag to locate any files that do not end in those patterns. And so this becomes a very useful tool, like I said, almost like find, except you get that really great tree pattern out. One more neat thing that I really enjoy about tree is that you can use it to not just match on the file names themselves, you can use it to match directories. So if I wanted to tree and look at just the reports directory and just the raw API directory, one of the ways you can do this is by passing these patterns as strings and then using the match dirs flag in order to ensure that we're matching on the directory level and not just the file name level. One thing that we can do with ls that's a little similar is we can pipe it into another program called grep. And so in this case, I've taken my output of ls, I've piped it into grep, which will search line by line for anything that ends in .csv, and it will return me what it found. This is a way of doing some type of true pattern matching on the output of ls, but you can see we need another program in order to do it, and we lose the full file paths. Now we can recover those by using a couple flags on our ls, but you can see here that this isn't a pattern that we always want to be doing. And I hope that somebody in the audience is thinking, Cameron, don't use grep on ls output. This is what find is for, right? There's a specific tool for this. We'll get to that, but I think for an interactive use, right, where I'm just using these commands and I'm visually inspecting the output to make sure things line up, I think it is totally fine to use grep on the output of ls. Where I might want to avoid it would be in a shell script or something where I don't have the ability to manually check that grep is correctly matching, right, my output from ls. And you also, sorry, one other caveat on that is that this grep won't just search for things that end in .csv. So if I somewhere in one of my folders have a tar.csv.zip, right, it'll actually pull that out as well. So you can throw in a couple, use a regular expression on the grep in order to make sure it only matches the end. But as you can probably tell, tree is pretty convenient. Tree also has a detailed view, which is great because it's kind of the counterpart to the detailed view of ls. So here you can see I've listed out the contents of our example directory, and now I can see the user permissions, I can see the user, the group that it belongs to, I can see the amount of space that it takes up. Kind of, right? Do we really think all of those directories take up 4,096 bytes? I don't think I'm buying it. But we can see the date that they were created as well as their file names. Now, tree can do this with limited success, in my opinion. And when we list it out with tree, my apologies. When we list it out with tree, we can see that we get our tree structure out, and let me add in one more flag here. And we can see the size of each of these files and folders. This is in human readable size, so we're not seeing things like 4,000 bytes. Instead, we see 4 kilobytes. And so this is still a great tool, right? It becomes a little less readable, in my opinion, when we throw in these types of flags, but still very useful if you want to take just a little closer look at what's in your folders. One of my favorite things about tree has got to be the fact that it follows get ignore file. So if you're in a git directory, it will detect your git ignore file, it will read it, and it'll say, I see that you want to ignore .env files and .pyc files. And so you haven't seen this yet, and when I run this, as I have before, you'll see here that, okay, well, we're not ignoring anything from git right now. That just happens to not be the default here. And so when we add in this .gitignore flag, you can see that our gitignore is respected. We're not getting any of the .pyc files that we were earlier, and we're not getting any of the files that exist under our .env folder. So this allows for a fantastic way of getting a lot of output, a lot of bang for your buck without having to remember 8 bajillion flags, right? I just need to populate my get_ignore, and then I just need to throw in the get_ignore flag. I don't need to tell it to, oh yes, ignore the hidden folder, ignore the .pyc files, ignore this, ignore that. It's just all in one place in your .getIgnore. It's just very convenient to work with. And so when we get here to the file details, we see a very interesting example. Let me uncomment this. We see a fantastic example comparing these two outputs. Right, and so the ls, where if we don't put it in the long detailed view, it puts the amount of bytes right next to the file name, and I already said this was hard to read, and if you thought it was hard to read before, it's honestly even worse now. So, one of my absolute favorite features of tree, and you'll see this with a lot of the modern tools, is that we can actually not get our tree-like output in the terminal. We can get, what is this? This looks like JSON to me. We can get JSON output. Heck, we can even get HTML output, right? And so what this lets us, why do we care about this? This isn't human readable. This is machine readable. And think, if you have something like a documentation site and you want that table of contents on the left, you don't need to figure out any fancy schmancy package. You can just save the output of tree into a JSON file, parse that in, load it up, and bam, you have a clickable, navigatable table of contents that's interactive. And so that's enough about tree. I do think it's a fantastic tool and something I will personally be using. But let's move on to exa. Exa, as you can see here, is very similar to ls, right? So these, on the top here, you see the output of exa, and on the bottom, you see the output of ls. Looks the exact same, so what's the big deal? The big deal is this. It's that. One, exa has colors by default. You don't need to set a flag for it, which I enjoy, but that's neither here nor there. But two, exa really excels at human readability here. On top, you can see the output from exa, and on bottom, you can see the output of ls. These have the same flags, and they're parsed very similarly between the two. But what I can see is that my exa output has headers on my detailed view of my output, which is fantastic because I always forget what they mean specifically. And so we see that we have permission, size, user, date modified, and the name of the file. It's really just really easy to work with and really easy to read. And so I have been enjoying the use of exa a lot. It does all of the same things as ls, and then it just makes it easier to read, easier to parse visually. On top of that, exa gives you your choice of output. Do you want to see a tree? Well, here's a tree, and you don't even need the tree command. And probably my favorite, do you want to see a tree with a list view? Heck, exa can even do that. And so I can see the structure of all of my files and how they map, as well as their permissions, what user group they belong to, etc. And so exa, honestly, to me, exa is one of my new favorite tools. I will probably be using it everywhere. Last but not least, exa is a modern tool after all, and so it supports Git natively. And so what you can see here, when I run exa with Git support, and then I show you the current status of my Git repo, you can see that there are a couple untracked files. Maybe they've been modified, but I have modified file 2 and file 3, and the untracked files are new. And up here in my exa output, you can see I have gained a new column called Git. Well, there's a new file inside the reports folder. Files 2 and 3 have been modified. file.txt is new, and there's a new file in the analyses. This is exactly what's in my git status, but it's up here in my detailed view, so I can see it in line with all the other files with an output I am highly familiar with. And so exa just kind of takes the cake for me. But the last thing as we wrap up this question, is it worth it? In my opinion, tree is at least as good as ls. I will be using tree because it allows me to capture the structure of the file system, and it also has that built-in git support. Also, exa, in my opinion, is really the combination of ls and tree, just about, right? Exa doesn't have that same pattern matching or inverse pattern matching support, but it has all the capabilities of ls. You can view the output as a tree. You can't capture it as JSON or HTML though, so that's a little nod there. You have modern defaults, right? Defaults to color, human readability, and it supports Git. And so to summarize all this, I will be using exa, I will be using tree. However, this does not mean I will ever stop opening up a terminal window, typing ls just to see what's there.